Next up, because the string data type is so important, we're going to cover it in the next several lessons. A string is a sequence of characters enclosed in double quotes. So we would type something like val s equal, how about big belly burger? It's a good one to work with. So that creates a string, and then as I showed in a previous lesson, you could declare it explicitly like this, but as you can see, that's just kind of a waste of characters. There's no real need for that. So I'll just declare the string like that. And because Scala is both a functional programming language and an object-oriented programming language, when I press S dot and then hit the tab key, you'll see that there's over 250 possible methods. So I'll just go ahead and say, I'll enter, oops, tab, yes I do, sorry, hit the Y, and then you can get a feel for just how many methods there are available on a string instance. I'm not going to show all those methods because you can really get by, golly, what is it? Maybe 95% of your time with 10 or 20 methods. But it's important to know that those other methods are there when you need them. So you can just look them up and say, okay, here's what I need to solve this particular problem. And we use these methods instead of writing our own for loops, which is another topic that I'll discuss shortly. But let's just focus on these methods for right now. So we'll start with some easy ones. So the first one, get a length of the string. So the length of Big Belly Burger is 16 right there. There's a capitalize method, so we could do that one. That capitalizes the first character in each one, and then we could say, how about 2 uppercase? There's another one that lets us do that. We can use methods like starts with, so we could say starts with B, and that's true. And then we could say ends with is another one. So we get the starts with and ends with are a couple that I'm looking at here. Ends with, and then here, because this takes a string, you could say it ends with GER. Is that correct? And it says true. The distinct method can be another good one at times, and we just say distinct, and that gives me the distinct characters. And intersect is a similar method. I will go with intersect. So this gives you the intersection of the current string S and then whatever I type in here. So what could I say? Big Belly Burger. So I'll just do like berry or something like that just to see. So that gives us the intersection of the original string along with this string, and that's the characters that are in both strings. And we're starting to get in that territory in these methods where a string is actually a sequence of characters. And what I mean by that is I can say, give me the first character of the string, give me the second character of the string, or let me even write a little for loop for each character in the string, print the character. In that example and the previous 2 examples work because a string is a sequence of characters. And so I'll keep showing a few more methods that work with a string, and in part they work because the string is a sequence of characters. So I could say take the first 3 characters of the string and that returns big, B-I-G. I could say drop. We could drop the first 4 characters of a string, and that gives me what's remaining, the belly burger. You can also do, so that drops from the left by default, and then you can say drop right. And then what burger is 6 characters long, so I could say drop right 6 characters. And that gives me big belly along with the space. So if I take care of that space too, then I have big belly. And similarly, take has a take right. So I could change that to take right, and that would give me that. The string class also has methods that are higher order functions, and I'll show what I mean by that in a few examples, but you've probably seen this already in other programming languages. So the first thing I'll do is I'll take that string, which is the Big Belly Burger, and I'll call map on it. And map could also be called transform because it transforms the string you give it, which is S in this case, using this algorithm that I'm about to pass in. So when you call map on a string, you can work with each individual character. So each individual character is passed into this algorithm that I'm typing in right here. And we'll just call c.toUpper, and that's a method that's available on each character. So you can see that transforms the initial string, which was all lowercase, into this uppercase string. And it's actually just as if I had typed in for, let's see, character in string do, or excuse me, this would be yield because I want to yield something new, and then this would be yielding to upper. And that gives me the exact same result. And so the way this method works is we go back here. All this stuff inside here is what we call an anonymous function or a function literal. And it's actually like a little mini function that we pass into the map method. And it says, map method, I know you're going to give me one character at a time. So what my function does is it transforms that character to uppercase. And in this example, my anonymous function is called 16 times by map, once for each character in the string. The result is that each character is converted to uppercase, and the resulting string is then returned. And that function literal would be just like if I had defined a method like this. So I could say, how about char, I'll call this method char to upper. So it's going to take a char as input. It's going to return a character. And then we just do c.to upper like that. And then if I had done s.map char to upper, we get the exact same result. So in this case, I passed in a function literal that has this algorithm. And then in this case, I created a function and passed that in here, and we get the same result in both cases. So we call map a higher order function, and that's only because it's a function and we pass another function into it. So if you ever thought higher order function sounded scary or anything like that, it's really not. It's just, this is probably the primary use case, is passing a function into another function. While I'm in this neighborhood, I'll also show you a shortcut you can use in Scala. When you're only working with one parameter and you're only working with it one time, you can replace that algorithm. So earlier I did C, and then I said C.to upper. And you actually don't have to type all of that in Scala. Scala is smart enough to infer that if you're only referring to it once inside that algorithm, that you don't need to do the C and then that, we call this a transform symbol. So you don't need to type that part in, the C with that transform symbol. You can just use the underscore. And then Scala is smart enough to know that that underscore is referring to a character, and then the character class has a to upper method on it. So along with map, another common method that we use all the time is filter. So here I could say, I want to filter, and what I want to do is pass in an algorithm. I want to get rid of all the space characters, so I could say where character is, I know there's a method called is the space character. So that would just return all the space characters, and I want to do the opposite of that. So I come over here and I negate that, so that gives me the opposite result. So this gives me all the characters in the initial string that are not space characters. And again, just like I did before, you don't have to have this C followed by the symbol there. You can just use the underscore. And again, Scala is smart enough to know that that underscore is a character in this situation. While I'm talking about the filter method, there's one thing I want to point out about it before we go any further, and then I want to discuss how to make filter work. So if we go over here to the Scala doc, and this is for the list class, but it could be for any class that has a filter method. The important part about filter is right inside of here, it expects this function that's passed in should be what they call a predicate. And a predicate is just a function that returns a Boolean value. So you can see that from this type signature here, filter is expecting, and this syntax is for a method, which we'll cover later in the discussion, or a function. But this is saying filter expects a function based on all of this, and it transforms the type A into a Boolean. And here A is a generic parameter, so right now we're dealing with a sequence of characters. So in our example, filter expects a function that transforms a character into a Boolean, which is either true or false. And so I showed that here in this example, but to make this more obvious, I'm going to create a function, and we'll call it is space char. And like I mentioned, it will take a character as input, and it will return a Boolean. So it's transforming a character into a Boolean. And then I can say, just call, I can call is space char on that character that's passed in. Okay, and this is just to make obvious what's going on here. So now I could say character, and then I could say is space character, like that. And so then I want the opposite of that for our example. And then we can go back to, as I mentioned, if you only use that character one time in this function that you're passing in, you can use the underscore there. So then I can say, give me all the characters that are not space characters in this string. And finally, because I don't want to get into all of the possible methods, the 250 plus methods that are available on a string, if you come to this, my website, and you come to this page, this is a collection of over 100 examples of string methods. So here in the top, I show some common methods in the string class, and like in these examples, I showed that you can get each individual element like that. I showed the length. I didn't show for each method. So for each is just another higher order function that lets you pass something in. So you could say for each character, I want to print line each character like that. So that prints each character. And then as we saw earlier, you don't have to do that part. You can just use that. And in some special cases like this, where you're only referring to that parameter one time, you don't even need to use the underscore. You can just use that. And then as you go along with this page, show that you can test string equality with equal equal, as shown in this section here. We're going to get into multi-line strings in a little while and string interpolators, so we'll come back to that. I didn't get into this in this lesson, but with strings, you can use regular expressions and regex patterns. Many of the methods come from Java, and then there's some other methods that implement more of a Scala way of doing things. So this whole section here shows how to use regular expressions. There's a regex class that you can use to create regular expressions. You can find all instances in a string. You can find the first instance in a string, and then I get into the replacement one, so you can replace the first one you find. You can replace all. And then I show down here a little bit about how to match dates. So these are all examples of using regular expressions with strings. You can transform sequences into strings, and this section shows how to do that. So you can format those. So by default, if you use mkstring or makestring here, that will create this string pattern. But you can also pass in characters here that will format the resulting string in different ways. And here's another example that I showed down here. One method here I didn't show before was diff. So you can show the distinct characters and the intersection between two strings. You can also show the difference between two strings here. These methods go on for quite some time, so I don't want to get into them all. But when you want to learn more about the methods that are available on the strings, I hope this is a good resource page that has well over 100 examples on how to work with these built-in string methods.